Hey, this is Vedat from Programmership. In this chapter, we are going to talk about closures. The definition is closures are self-contained blocks of code that can be used in the application. We can think about it as a type that contains a block of code. Closures can also contain parameters and are able to return a value. It is alright if you don't understand it from a definition. As always, it is better to see that in an example. Let's define a basic closure. Let's say var my message is equal to, and then I will open my curly bracket and close it. Here I want to define a closure without any parameters. So you can put parameters between these parentheses or leave it as empty. And the return type will be void, because I don't want to return any value for now. And then I will use the in keyword for separating the closure definition, in other words, the closure signature from its body. So now inside the body of our closure, I want to just print hello world. Now let's call the my message closure. It is just like a function call. Just say my message and put its parentheses. Let me hit run. And as we can see, it says hello world, so it works. As I said, we can also define parameters in the closure signature. Let's add a string parameter inside the signature. Let's say name, and that will be string. And now let's call the my message closures again, but this time we're gonna pass a string value for the parameter. Let's say Vedat. By the way, inside the closure, let's print our parameter instead of world. Let's say name, and let me hit run. And this time it says hello Vedat, which is our parameter. Pretty cool. We can also add multiple parameters in our closures. So let me add some more. Let's put a comma and say surname. This is also string, and let's add an integer. Let's say age. It is integer. So inside the body of the closure, we can say hello name and surname, and then say you are age years old. And in the calling of our my message, let's pass other parameters. Let's say Oslo for the surname, and for the age we can say 26, and hit run. We can see the result. All the parameters was printed out. So now let's try to return a value from my message closures. So here inside my message, I want to return a string value. Let's say string. And here instead of printing, let's just say return, and I will return this string definition. Here outside of the my message closure, we can just print my message closures. When we try to call it, it will return back this string. So let's hit print, and it works. As I said, we can use closures as type. If it is a type, that means we can use closures as a type of a function parameter. Let's delete all of this. And now I'm gonna create a simple void closure, just like I did before. Say var my message again is equal to, and inside the curly brackets, I will define my closure signature. So it will be super simple. I don't want any parameters and return value. So let's say void for that. And inside the body of the closures, we can just say hello world, just like that. And now I will create a function that will accept a parameter, which type is closure. Here our closure has no parameters and it is void type. So let's define a function. Let's say func, let's say message engine, and inside I will add a parameter which type is just like the my message closures. Let's say message handler for the parameter name, and the type will be just like that. Let me copy this signature and paste it. Here inside the function body, I will just try to call the message handler parameter. Remember, its type is closure, so we can call it. So it is time to call message engine function. Let's say message engine, and inside I will just pass my message closure, and let me hit run. So it says hello world. It works. Awesome. Let's add some parameter in the signature of my message closures. let's say name, that will be string. So if I add a parameter, then I need to change the signature of my message engine parameters type. So let's copy this parameter and paste it here, and inside the message engine I just pass some parameter, let's say Vedat, and we can also print the name parameter inside my message closure, let's say hello name. And here in this line, let's hit run. So it seems we have an error. I think instead of specifying the name, we can just delete and leave it as empty. Let me hit run again. And it works. Here inside the my message closure signature, we can also remove the parameter name and leave their types only. But this time we need to make a few changes in the closure syntax and use a shorthand for accessing parameters. So let me delete the name parameter and just leave its type. So inside the my message closure, I will just use the dollar symbol and 0. This is a shorthand for getting first parameter. So $0 means first parameter of our closure. And just because I don't use any name definition inside my closure signature, so let me delete this curly brackets and add it instead of in keyword. And also here I will just say my message type is this and its body is equal to this definition. So as I said, when we use this kind of definition, we need to do a few changes inside the syntax of my message closures. And now let me hit run again. So it still works. Even we can also add multiple parameters inside my message. So let's add another parameter and that will be string. And we can also add an integer parameter as well. So inside the body of my message closure, let's call the other parameters as well. So for the second string parameter, I need to use again the dollar shorthand, let's say dollar. If I say 1, then it will represent the second parameter of my closure. And also, let's say you are my third parameter, which is $2 years old. And now inside message engine function parameter, let me copy this signature, paste it inside the message engine function, just like that. And also, let's give some values for the parameters. Let's say Oslo. For the integer, it must be integer, and say 30. Let me hit run. And we can see all the parameters was printed out inside this print statement. We can also make our code much cleaner if we can give an alias for our closure signature. I will use type alias for that. Here, let me define a type alias. Let's say type alias, and I can say my closure for a name is equal to, I will just copy this signature and paste it here. So from now on, I can use my closure name instead of this signature because my closure now represents this signature. And I can also use my closures inside the function parameters as well, just like that. You can see it is more readable. So let's hit run and it still works. Well, I want to show you something. There is a method called map that can loop through each item of a collection. This map method accepts closure as a parameter. We can use closure to create some logic. First, let me delete all of this and create a basic string array, and then we'll see how map works. Let's say var my array is equal to, and inside the array, let's add some string value. I can say apple, let's say orange. And the third one, we can say banana. So in the next line, I will try to use map function of my array. Let's put a dot and say map. Here in the definition of map, it says returns an array containing results of mapping the given closure over the sequence's elements. Let me hit enter and hit enter again. So here, the string represents our items of the my array. Just because our my array is string type, this parameter also need to be string. Let's give it a name. Let's say my fruit. And here, after the in keyword, I can just print the my fruit. Let's hit run. and it shows all the items of my array. We can also remove the name declaration and use dollar symbol for shorthand. So let me delete this, and inside we can just say $0 because it only has one parameter. And let's hit run again. Still works. Let's make each item of my array uppercased. Here inside the print statement, we can just say dot uppercased and hit run again. It is now uppercased. Cool. Remember, map method returns back a new array. For that, we can use return keyword, but our original myArray will not be affected by any change within the map. Let's get the uppercased items into a new array. So here I can just say var my fruits is equal to myArray.map. Inside the body of map, we can just use return keyword instead of printing. And here, let me first loop through each item of my array and see it is still the same. Let's say my array dot map. Here I can just use dollar syntax and let's say print $0. Let me hit print. And we can see it is still lowercase. But if I try to map through my fruits array, it must be uppercase. Let's copy this and paste it here because it is all the same. And let's hit print again. See that the first three item is my array's item, but the last three items were uppercase. It is my fruits item, so it works. Now I want to make a different kind of example. Suppose we have a student list that contains students' name and their score. We will find which students are hardworking and which are lazy. First, let me create a dictionary that will store our student list. Let's delete this and say var my students is equal to our dictionary will have a name for our student and also the score. At first it is empty. Let's add some students inside my dictionary. Let's say Alex, and its score will be integer. Let's say 70. I will copy this line and paste it a few times. For the second student, let's say Thomas, its score is 30. Let's add another one, Isaac. Its score is 85. And finally, you can say George, which score is 20. And let's map through each student and see if everything is right. Say my student.map. Here inside the body of closure, let's say print the $0, which is the name of our student. Notes is, and I will grab the student's score. Let's say $1. Which is this. And we can also delete this signature and let me hit run. It works, cool. Now I will create a type alias for the closure that our my student dictionary needs for mapping. At the top of my students, let's say type alias, and I can say student info is equal to, remember our my student dictionary has two different types. These are string for the student name and integer for each student's score. And return type is void, just like that. And it's time to create closure for hardworking students. Let's say var hardworking students, and its signature will be student info. The body of the signature will be, let's add a basic calculation for hardworking students. Let's say if the score, which is $1, is greater than, let's say 50, then print our student name with its score. I can copy this definition and paste it here. It's all right. And let's also create a closure for our lazy students. Let me copy this hardworking student closure and paste it. I will just change the name. Let's say lazy students, sorry for my typo. Inside the body of the closure, I can say if the score is less than or equal to 50, it is lazy. Alright, here let me delete the my student map and I will just try to find which students are hardworking. My students dot map, and inside the map method just pass the hardworking students. And let me hit print. Yeah, it shows the students whose scores are more than 50. Also, let's display the lazy students. Let's say lazy students, and let me hit run again. So these are our lazy students. The scores are less than 50. Well, finally, I want to make an example that will show you how closures are very useful. Suppose we have a login page in our app where users must log in. In a real-world application, we make network requests for login operation, and this request must be done in a background thread. But now I will try to keep everything simple to explain closures in login operation. So there won't be any network request or background threads, etc. Let's create a login function for that. Let me delete all of this and say func login. Inside we need a username for login, also a password. So the third parameter will be a closure, which will handle the login result. Let's say login handler, and the closure signature will be results boolean. It will represent the result of login operation, and it will return back nothing. Let's say void for that. So we can also omit the result name as using underscore for the external parameter name. Here inside the function, let's suppose the network request in a background thread for login was handled. And in the next line, I want to create a basic login logic for our function. Let's say if username is equal to password, then our login success. Let's say login handler, and for the parameter I just pass the true. If login is not success, just pass false for the login handler. Let's say false. Now at the outside of login function, I will try to call it. Let's say login, and for the username, let's say Vedat. For the password, I just say 123, and for the handler, let me hit enter. We can see it says result for the parameter name of login handler, and inside the body of closure, I can just say if result is true, let's say print successful, else if login is not successful, then print login failed. Here when we call the login handler inside the login function, this closure will be triggered and the result will be assigned by the value that we passed through login handler. And inside the body, we just check if the result is true or false. So let's hit run. And it says login failed. Why? Because inside the login method, we just create a logic which username must be equal to password. And here, when we call the login function, we just pass different information. So let's say Vedat for the password and hit run again. We can see it says successful, so it works. Here, if we would make a login request to a network in a background thread, and even if the request could take some time until a response comes back from the network, we can still get the network result within our closure. It is very powerful to use closures in asynchronous operations. Alright, that's it for today. I hope you have learned something about closures. See you in the next one. Goodbye.